Hello and welcome to Let's Design Any Machines. In this Spur Gears series, I'll make a spur gear of an involute curve and make a configuration outfit for the first part of the series. For the second part of the series, I'll make the gear's shafts, assemble all the parts, and make another configuration of that assembly. The third part of this series, I'll make motion simulation using motion analysis, and this motion analysis will look like this one. So after making this motion analysis, I'll compare the results of this motion analysis with the results of dynamics equations. So first I'll make the first gear, which is this one, and then I'm gonna make a configuration outfit that looks like this one. So I'm gonna close this assembly and open a new part. So before making the first spur gear, I'll introduce you to some of Spur Gears terms. So this image, which is this one will help me demonstrate these terms. So as you can see here, these are abbreviations for the terms that I have talked about. So AC represents the addendum circle, BC represents the pitch circle, and BC represents the base circle. DC represents the Dedendum circle. All these terms have their own equations. So I will open this file. As you can see here, these are the equations of the terms of spur gears. So this is the addendum circle diameter. This is the Dedendum circle diameter. It's the pressure angle, base circle diameter, number of teeth, fillet radius. So fillet radius is as you can see here, is the radius of this small curve. So, and we have the circular pitch, which is the length of this curve, as you can see here. So it is the length of this curve that starts from a point on one tooth and it ends at the corresponding point on the other tooth. So we have here the angles of the spur gear tooth. So we have angle number 1, or theta 1, theta 2, and theta 3. I'm going to open this image to help me to help us see these angles. So this is the first angle, which starts from here, which is at the beginning of this tooth, this line. So the second angle is from the end of this line, the end of this angle, number 1, to the middle of this, to the center line of this tooth. The third angle is the addition of the first angle and the second angle. So it's from this line to this center line. Then we have this involute curve equations. These equations will help me form this curve, which is I'm gonna open this image to see the involute curve. It is this curve that starts from this base circle and it ends at the addendum circle, which is on the top of this gear. So this X and Y, that represents the X-axis and the Y-axis. So every point on that curve will have distances in X and Y axis. So when combining all these points, we will have this curve, which is the involute curve. So for the gears, I have pre-calculated the variables of the first gear A and the second gear B. So all I have to do is copy and paste the names for these dimensions and their values into SolidWorks. So now I'm gonna start by making the first spur gear. I'm gonna go to Features, Extrude Plus, and choose the front plane to sketch on. I'm gonna sketch the Dedendum circle. Choose the Smart Dimension to give it a name, which is here, and the value of this dimension. I'm gonna go to my file and I will copy the Dedendum diameter, which is this one. I'm gonna copy this name of this dimension. I'm gonna paste it using Ctrl V. The same goes for the value. So I'm gonna exit the sketch. I'm gonna choose a thickness of 10 millimeters. So I'm gonna change the name of this extruded pass. I'm gonna I'm gonna right click on this icon and then go to features, feature properties, and in the name window I'm gonna call this thickness. I'm gonna make another extruded pass, which is gonna be the teeth of this, one half of a tooth. I'm gonna sketch on this face. First I'm gonna sketch the Addendum circle. As I did before, I'm gonna copy the name of this dimension, paste it in SolidWorks. Then the same I will do for its value. I'm gonna make the pitch circle. Of course, I will add all these equations and values to the comments, so you can practice on these values and equations. I'm gonna make the base circle. So I'm gonna make the pitch circle construction geometry, since I don't want to extrude it. Gonna make it, as I said, the construction geometry, and the same I will do for the base circle. I'm gonna add the Dedendum circle. I'm gonna move these dimensions a little bit. Now I'm gonna make the involute curve. So all I have to do is to go to spline, and I will click on this arrow and choose equation driven curve. So in the equation type, I'm gonna choose parametric. So this is the x-axis and y-axis for the involute curve. So I'm gonna go to my file and copy and paste these equations. So they have to start from 0, and this one is going to be 0.08. So it doesn't matter where it ends, as long as this involute curve passes this addendum circle. So I'm going to check OK. So I'm going to add some relations here. I'll go to display delete relations. I'm going to click on this arrow. I'm going to add the relation. I'm going to clear these selections. I'm going to click on this point on this curve and the base circle. For the relation type, I'm going to choose coincident. I'm going to add a line from here and here. So you can see that these two lines have turned from being blue to be in black colors. I'm gonna make this line a construction line. So I'm gonna add another line here. And this also will be for construction. I'm gonna cut this additional part of this curve. I'm gonna add some angles to make these lines and this curve to make it fully defined. Because when they are blue, they are underdefined, but when they are turned into black, they are fully defined. So I'm going to add some angles. So first, before adding them, I'm gonna add another line here, which will be coincident on the pitch circle, and add a relation between this point on this line and this curve. Make it coincident. I'm gonna add a smart dimension. So the angle between this line and this line will be the first angle. I'm gonna go to my file and copy. The name of this first angle and its value. Now I will go for the second angle, but before, we can see here that the curve has turned from being blue to be in black color. The reason for that is, as I said before, it turned from being underdefined to be fully defined. So now I'm gonna add the second angle. I'm gonna go to my file, gonna copy its value, now the first part of this tooth is ready to be extruded. I'm gonna exit the sketch. I'm gonna go to the select contours, gonna check this region. So I have to look at the extrusion direction. I'm gonna make it in the reversed direction. I'm gonna check OK. Now the first half of our tooth is ready. All I have to do is to mirror this half to the other side of this face. For that, I'm gonna need a plane to do that. First, I will go to reference geometry. I'm gonna choose plane. For the first reference, I'm gonna choose this face and make it coincident. And check OK. I'll go to mirror. For the plane, I'm gonna choose this one. For the feature, I'm gonna choose this extruded boss. Now we have our first tooth. Gonna hide this plane. I'm gonna change this, the name of this extruded boss to be half tooth. Now I'm gonna make a circular pattern. For the direction, I'm gonna choose this face, and for number of instances, I'm gonna go to my file and see the number of teeth, which is 20. That's right. So for features and faces, I'm gonna go to faces to pattern, and choose all these faces. now we have our gears, our tooth actually. So but I have forgotten actually to make the fillet. So the fillet, I'm gonna add it, but before this circular pattern, all I have to do is point my cursor on this line, then gonna pull it up. Now I can add the fillet. So I'm gonna choose this line and this line. I'm gonna go to my file, see what is the radius of this fillet. Gonna copy it, gonna go to here, the radius, I'm gonna paste it, then I'm gonna check OK. Now we have our fillet. All I have to do now is to pull down this line and have to edit this circular pattern. All I have to do is right click it and go to edit, and for the faces I'm gonna add these two faces of the fillets. I'm gonna check OK. Now it's ready. Now I'm gonna make the hub of this gear. I'm gonna draw a circle here. Hub diameter. And it is 30 millimeters. I'm gonna check OK. Exit the sketch. Gonna make under direction 1 through all. Now it is ready. All I have to do is now to make a configuration out of this spur gear. So I'll go to configurations, manager, which is here. I'm gonna right click this part 1. I'm gonna add a configuration. So I'm gonna call this configuration B, and I'm gonna change, or I'm gonna change actually the name of this configuration by right clicking the configuration, go down to rename item 3 or 3 item. So I'm gonna call this A. Now the way I'm gonna make a configuration out of this is by using design tables. So to add a design table, I have to go to this drop down menu and go to insert. I'll go down to tables and choose design table. I'm gonna check OK. Now as you can see here, it's like an Excel file. So we have, when you click outside of this Excel file, you exit that Excel file. All I have to do is to go back to configurations. Folder and go to this file, which is the design table, and right click it and choose edit table. As I said, this Excel file has columns and rows. So the columns represents the column represents the features or sketches which are here, and the rows represents the configurations. So to add a feature or a dimension, all you have to do is double click that feature or dimension. I'm gonna show you how. Well, the thickness, I'm gonna add this extruded boss by double clicking it, and then for the dimension I'm gonna click on the sketch. I'm gonna move this a little bit, and then in here I'm gonna double click on this dimension to add it. We can have a small sound when adding this dimension. So I'm gonna add this the half tooth. I'm gonna add these dimensions, starting with the addendum circle, edge circle, base circle, dedendum circle, and now for the angles, theta 1, theta 2. Now I have finished the first half of the tooth. I'm going to add the plane. All I have to do is to click on this column and double click this plane, and then the mirror, fillet, but I'm going to add its dimension by double clicking it. You can see it here, and the circular pattern, I'm gonna have to move it a little bit, see the number of instances. I'm gonna double click this dimension to add it. And the Extrude Cut, I'm gonna add it by double clicking it. I'm gonna move it a little bit to add its dimension. So now we have all the dimensions for our spur gear. So we can see here some we can see here unsuppressed. We can suppress or unsuppress feature by typing suppressed or unsuppressed. So for this I'm gonna make it unsuppressed by dragging this down or typing it. So for the Dedendum circle for B, I'm gonna go to the file and go down to the second gear, which is B. All I have to do is to copy this value of this Dedendum circle diameter and paste it here. Now for the Addendum circle diameter, I'm gonna copy this value, right click and paste it. I'm gonna this column a little bit and this too. Now the pitch circle, gonna copy this value and paste it here. The base diameter, which is this one, gonna copy it. Again for the Dedendum circle, Now for angle number, first angle, theta 1, gonna copy this and paste it here. Now for angle of theta 2, gonna copy this value and I'm gonna unsuppress this feature, which is the plane number 1. And the mirror, the fillet, and the fillet radius is the same as the first gear, since they have the same module. So I'm going to unsuppress this pattern. Now number of or the number of instances, gonna go to number of teeth, which is 40. Gonna paste it here. I'm gonna unsuppress this extrude cut and the hub diameter, which is 60 millimeters. Now the other gear is ready. I'm gonna click outside of this axle file. I'm gonna reload. All I have to do is go to the configurations and double click on the part P, and we can see here we have a new gear. So now I'm going to add extruded cut here. I'm going to go to the first part. I'm going to add extruded cut here. The reason for this is when this gear turns around its shaft or axis, I want to know the direction of its rotation. So this extruded cut will help me distinguish the direction of rotation, whether it's clockwise or counterclockwise. So I'm gonna draw a circle, this circle, and before doing anything I'm gonna click on this arrow. I'm gonna choose for this configuration. I'm gonna make this circle diameter 5 millimeters, and this radius is gonna be 20 millimeters. But before adding this, I'm gonna set this dimension for this configuration, and this thing I'm gonna call it radius. Gonna change the name of this dimension. All I have to do is drag it a little bit, and this window will pop up. I'm gonna change the name of this dimension. I'm gonna call it diameter cut. Just an abbreviation for this cut. So I'm gonna exit this sketch. Gonna make this through all, so it will be through all the gear. Now I'm gonna go back to the design table to add this extruded cut. So all I have to do is enable edit table. Now since there is a new thing, that has been added or new things, I'm gonna check these things to add them for the design table. All I have to do is control click these features. Gonna click OK to add them. Now they have been added automatically. So here I'm gonna make it, as you can see, if I click on this feature, this window will pop up. So I can choose S, U, or 1 or 0. S stands for suppressed, U stands for unsuppressed. Same goes for 1 and 0. So I'm gonna choose unsuppressed and choose unsuppressed for that, for configuration A and B. So here I'm gonna make the diameter of this cut 20 millimeters, and its radius is gonna be 60 millimeters. Gonna check OK. If I will go to B, the radius is a little bit big, so I'm gonna reduce it. I'm gonna go to design tables and change the radius of this cut. So I'm gonna make it 50 millimeters or 45. I hope that I guessed it right. Oh, this one is, oh, sorry. That one's the hub. So I'll turn it back to be 60. I'm gonna go to the die cut, which is the distance between the center of that cut and the center of that circle of that cut. I'm going to change it to be 60. Here, no, not here, I'm sorry, it's going to be 10, and this one's going to be 50. I can see it's a little bit right. Gonna change it to be more appropriate. Gonna make it 40. Gonna check OK. Well, the position of this cut is a little bit appropriate than before. I'm gonna save these parts. Gonna make a new file. Gonna call it Gears. Oh, sorry. So this is the end of this video, or this part of this series. I hope you have enjoyed it. So I will see you in the next part of this series. Thanks for watching.